Okay, fantastic. So maybe let's get started. Hi, folks. Once again, this is our weekly Yugabyte Friday Tech Talks, and it's a pretty technical talk. It's going to be this week's topic is how do you achieve zero downtime in your applications? And have with me here Franck. Again, Frank's no stranger. He's been doing a bunch of these. But anyways, Franck, maybe quickly introduce yourself for the new folks, and we can get the show started. Once again, feel free to, by the way, add questions right there on the LinkedIn comment. You can also join our Slack, yugabyte.com/Slack. So, but yeah, go ahead, Franck.
Yeah, so I'm developer advocate. So here's showing the different features we have and that can answer the questions from users. So yeah, question in the chat will be welcome, of course. So deployment of option for achieving zero downtime. The first thing that I want to explain is that even if we build a database, we need to think about the resilience in terms of a user connects to an application and then to the database. There are many databases that can be highly available, but if the application is not behind that, it will not help a lot. So the idea here is in a cloud deployment on 2 zones, and we will see that it can be multiple regions as well. In each zone, we have a bunch of instances and local storage there, block storage there, and they communicate between themselves by the network. And that's the database, highly available because there are multiple nodes and replication in it. But usually the application will be also highly available in multiple availability zones, and they will connect to the nodes that are in the same zone because it makes no sense to add latency on it. They see the whole database from each place. So usually this is the kind of thing. And of course, there are users. There are things that can be run by batches or event-driven things from there. But usually users will connect with a load balancer that will balance to the different regions. And then what we want is that in the worst case, this is the worst case, but this is probably not the most common. If a whole data center is down, that's the kind of easy case because the load balancer will just not balance there because nothing is there. There is no network, there is no servers. And then everything continues here because of redundancy, the new leaders are elected there and everything works. That's the easy case. But it basically never happens. Usually only a few components are failing, like the network there. And even if the whole data center is down and burns, probably the components will not stop at the same time. So you have also a certain time window where only some components are down. And in this case, the problem here is that the database cannot communicate, so cannot synchronize, but the users can still connect to the application. And then if they see this part of the database that has no quorum, they would read stale information. So
I think this diagram also brings up another interesting thing from a slightly higher level, which is that your application also should be ready to get distributed across these failure domains, right? Like it cannot be like, for example, the traditional way of writing applications would be to have a session cache or a write-through cache, and it would be very stateful and it would do a whole bunch of stuff. And so that type of an application paradigm doesn't quite work in a cloud native world, right? Like you should be ready to run multiple instances of the application across your different fault domains. And so some loose synchronization of what your database provides with what your application architecture is becomes important, right?
Yeah, and also we are talking about resilience there, but for elasticity, if we have the workload that increases, we probably need to increase the database, but also the application.
Yeah, perhaps we can explore that in a future YFTT. But yeah, for now, let's stick to the lower layer and how do we give the guarantees, assuming the application is written well, right? So
yeah. So then in this case, in this case, what happens there is that Yugabyte will not accept reads and writes if it doesn't have the quorum when discussing with the other zones. And that's also a difference. Most traditional databases with primary standbys I've seen, of course, they will not take the writes if they are replicated in sync, but they usually accept the reads And then you have a read split brain where you read stale information, which can be okay for some reporting, but not okay for something more critical.
Yeah.
So then basically, when we talk about downtime, we talk about failures. So any component can fail. A node, disk, can be disk corruption also. Isolation from the network partition, or manually stop for maintenance. And maintenance is, we think about upgrades, but that's also security patching that we should do quite often, key rotation. So we are talking about failures there, but can be a planned maintenance.
Mm-hmm.
And then what means zero downtime? What is the resilience? The application continues transparently and can recover also. So first, the failure needs to be detected. Not only, I mean, we can build old components, but if the failure is not detected, then the application will not continue. And read and write will continue, the new leader for the Raft protocol. And of course, some connections can be connected to the node that fails, and they have to reconnect. If it's a full availability zone, the application is gone also, so there is no connection from it anymore. And most important, no split brain, because if there is a failure and a disaster, you will have enough stress and problem. You don't want to think about all the little side effects on the data. So the database must stay consistent. And automatic repair, because failures can be transient, just a network failure for a few minutes, and then everything should come back. Can be also disk corruption, for example. It will be automatically repaired. So then what?
Yeah. But I think in the previous thing, I think it's actually very interesting to call out that while we are discussing these things, like, you know, they are the rare case, which might have been true for a traditional database in a non-cloud native architecture. The whole power of cloud native is to go to commodity servers, right? That's what gives you the cost drop, right? Like that means failures will happen very often. And so this has to become a more exercised regular path as opposed to a rare, sometimes it happens and we deal with it kind of path, right? Like, wouldn't you agree?
Yeah.
With that, right? Yeah. So that's...
And the failures have changed.
The type of failures.
On premises in data centers, you have different failures. Usually you have reliable network hardware because it's yours and everything is redundant.
Yes.
But you may have other things like just power outage. In the cloud, some other failure may come from commodity hardware. So that's also has changed here.
Yeah, makes sense. Makes sense.
So the most simple deployment is a single region. In single region, you have multiple availability zones. So here I've represented one of the leaders, and he has to synchronize with the followers, Raft protocol, the quorum. So if we have 1 millisecond between availability zones, the writes will wait 1 millisecond. And to protect the region in case of region failure, we send backups to S3, for example, in another region. If there is a failure in an availability zone, then everything continues and with the same latency because we have another follower. So we have the quorum within those 1 millisecond. So that's the easy case for performance. And it's okay if you consider a region failure as a big disaster where you have time to restore a backup and maybe have some data loss. But if you want more, if you want to protect for region failure, and that's something that can happen, then we need to deploy across multiple regions.
Yeah.
And the first thing we may think, because in the previous diagram, I've put a backup in another region, we may think about putting one of the followers in a remote region. That can be helpful for reads, to read from followers, but I want to show quickly that it doesn't improve anything in the resilience. Because if one AZ is down, application continues, but with higher latency. because now the quorum has to go to the follower there. So
yeah,
that's longer. And if the failure is between the two regions, we just have no advantage. Everything continues, but this doesn't provide anything in the other side. So stretching only one follower out of the region doesn't really make sense. We have no additional protection. Can be used for read, but then in that case, we can also have read replicas. They do not count in the quorum, and then they will not increase the latency in case of failure. And this doesn't protect for a full region outage. If the full region is down, this one doesn't have the quorum, and without the quorum, the database cannot transparently recover because first it doesn't know that everything is gone. Maybe it's a network issue and people are still continuing to write on the other side. So you cannot automatically decide to have a split brain. And also some data may not be synchronized there. So this is not used for disaster recovery. In exceptional case, of course, we may find the data there, but that's a lot of work, and this is not what we want with zero downtime, because then it's hours of or days. So basically, to do multi-region, we will have 3 regions to get a quorum between them. So the closer the regions are, the lower the latency is. This is an example in regions in Europe, and I have an example that is running there. I will show it now. I created that on our cloud. Here I have a cluster with nodes in London, in Frankfurt, and in Paris. And I have some inserts running in the background that I can see there. So I'm inserting 10 rows. I have 3 indexes on it, and this is still in 15 milliseconds. I think we can check the latency also there. Average YSQL latency, 15 seconds. And if I look, I started that a few hours ago to be sure. Yeah, we have the latency also here. So it's very homogeneous during the time. So we can be okay with 10 milliseconds latency. That depends on the application. It's not a latency per row. It's a lot of things are batched when communicating with the different nodes. And also I achieved that because I've put all the leaders at the same place. That's also a solution, because if you have leaders in different places, for example, here I have 3 indexes. If they have the leader elsewhere, then it has to synchronize with other region. Here, I have the preference with double spaces.
So one question, Frank, from Kurt, right, and is that in the US, there are very few regions that are in the tens of millisecond latency. US East 1, East 2 may be the only example, or maybe there's a couple of others which are in the 10 or 20 millisecond range, right? So one question is, what happens if one of the sides is small and the other side is big? Because that's essentially...
Yeah, that's a possibility. Basically, if you don't have the possibility to have them closer, then that's a possibility. And in normal circumstances, you will have the latency from the closest one, because that's the quorum. And then you will have the 10 milliseconds. And in case of one region failure, then the latency will increase. But yes, in the US, that's US East, 1 and 2, and there is one more in the West, which will be probably 100 milliseconds.
Yeah, makes sense. And and one other question, which is like just something that I just wanted to bring up, which is another thing we notice, is that in this case, this is a replication factor 3 across 3 regions, right? One of the issues you could have is, let's say a region goes down, right? That means one of these areas is out, right? And that means now you cannot take even a node failure, which can be more common, like, because the region failure can take a while to recover, right?
Yeah.
So what would you do in that case? What is the solution to solve?
Yeah, basically there, if one region is down and just one node fails, then probably you lost something, because you have distributed your data on multiple nodes. So you have many tablets on this one. Then you have to go to replication factor 5. And then with replication factor 5, you have that. But that can be okay in a cluster with lower latency. If you go replication factor 5 and you have only one region that is 10 milliseconds and the other is 100 milliseconds, then you will add some latency.
All right. So then you'll put two replicas each in the nearby regions and one replica in the faraway region, right? So that's how you.
Yeah.
So you still get low latency, all of those characteristics.
Yeah.
But now you take region and maybe a node failure, because nodes can just happen over the period of time a region is recovering, right? So
yeah, that's a good point. And the region can take longer. It's
it could take
rare,
like
but
days, and during that time you're susceptible now. Okay, got it. Makes sense. Yeah, makes sense. Awesome. Okay.
And when we do geo distribution, then we were talking about this additional latency, but we can choose to distribute everything and have the leaders in a preferred region to avoid, especially if the application is joining a lot of tables or updating a lot of secondary indexes, better to have them close together.
Yeah.
And also there is the possibility to geo-partition. So first, maybe you geo-partition just because you need to, like putting GDPR data in Europe and things like that. So there, the idea is that you want to manage a multi-region cluster, but for some tables, for some partition, you put them in a specific region.
Yeah, makes sense.
Well, that's the same balance. You have lower latency, but then you have all followers in the same regions.
Yeah, makes sense.
But can also make sense because if there is a big disaster in Europe, users from Europe may accept that they have a problem. Users from US may not accept that the database is down because of a region in Europe.
Yeah, makes sense. Yeah.
So then the big question, we have been talking about quorums a lot. And then the question is, what if we have only 2 regions?
But before we go there, there's a question from Venkata, which is 5 replicas won't be enough when a region fails and a node in another region fails. Don't we need at least 6 replicas since 3 nodes can fail? 2 in one region and 1 node failure simultaneously.
So if we have 5 replicas and 1 fails,
I think that
we still have the quorum.
Yeah. So Venkata, I think you won't have 3 nodes in one region. You will have 2 nodes in one region, 2 nodes in another region, and 1 node in the third region, right? So in this case, if you lose a region, you will lose at most 2 nodes.
Yeah, that's the point. The 2 level. You need to have the quorum on the region and then the quorum on the nodes.
Yeah, in Venkata's case, if you assume that a region failure will take it out, you're right. We will need another region in play. Yes, that is actually correct. You will need the same replication factor, but you will need to distribute over 1 more region. So it's a good point, Venkata. I think I was talking more about zone failure than region failure, but yes, you're right. I think we will need 1 more region. Yeah, that's an accurate point.
Yeah. Exactly. So when we have only 2 regions, and that can be, we're talking a lot about cloud, but people are running also on premises, and having 2 data center not too far for latency is quite common. 3 data center is a bit more. So what if we have only 2 data centers or 2 regions? Then this is where we need another technology than the consensus that needs a quorum, and this is why we have the cross-cluster replication. And basically, the idea there is that you cannot stretch the cluster, so you have a cluster in each region, and then replication between them, but asynchronous replication between them, not WAFT-based, not with the quorum. So that's the idea. 2 regions with their own single region high availability, and then they can replicate their change to each other. So low latency locally and data residency if needed. In case of region failure, then you can switch to the other. The idea of that, even if on the PowerPoint we can replicate everything in bi-direction, we don't want to put more complexity with replication conflicts. So the idea of this schema is that we have everything running with replication in both ways, but we will connect to only one. The other one is considered as in standby. And in case of failure, we can just have the application connect to the other. So the data loss is minimal. It's asynchronous replication. Of course, it will depend on the latency, but the data loss is minimal, and we switch to it. So basically, one primary and the other is in standby. We can reverse the roles, for example, for maintenance. And we have a new feature, I think I mentioned it there. We have a new feature in the latest versions to be able to do that, waiting to be sure that we do not lose any data in case of switchover. So that's a possibility. And we can also balance data if we are sure that we do not touch the same data set. Because both are active and being able to take writes. So for example, if I have multi-tenancy, I can run some tenants on one and some other tenants on the other to balance the load, and also maybe some tenants need lower latency from one region or the other. So that's basically how we add to the synchronous replication, we add asynchronous replication. But it's not really added on top of it like another technology. It's still based on the same, we replicate the same changes. We just replicate them differently, not with a consensus, but with asynchronous replication.
Yeah, makes sense. And I think one point that Kurt brought up, I mean, it's a basic point, but it's still worth calling out, is that in this case, the RPO is not zero, which means there will be some data loss on flipping over, right? Or yeah, exactly.
And the consequence when RPO is not zero, in many cases, it will not be an automatic failover. You need a manual decision when you have data loss, except if it's the kind of application where, for example, you are ingesting IoT data or where you can accept that. But usually, if you have data loss, you have someone who will decide, and will decide also. You need to estimate the failure. If it's a region failure for 1 minute, maybe you prefer to wait 1 minute and lose no data, or to switch immediately and you don't care about data. So this is why it's usually manual, except if you really prepare in advance the recovery plan, and you can decide on some criteria. But asynchronous replication, if you cannot have RPO 0 and the best performance, of course, for region failures.
Yeah, makes sense. Awesome. Yeah, keep going. I think you were okay. So 217, you had some features there. Yeah, that's fine. Yeah, keep going.
Yeah, there is the latest blog in our blog. The latest post is about those new features. We have also transaction atomicity that was not yet there to be sure that we read something consistent also on the other side.
So,
the cross cluster can be used also simply to read, to do some reporting on data from another region also.
Yeah, and to recap the difference between these two approaches, besides 3 region, 2 region, whatever the minimums, in one case, like the synchronous case, it's going to be automatic and it's going to be guaranteed data correctness, right? Like you won't lose any data, but the latencies could be higher, right? Like depending on the exact details, right? Like Kurt saying, if you don't have nearby or if you have a failure, etc. Whereas in the other case, it's not automatic and you could lose some data, but the latencies will be lower, right? So that's really the decision criteria on which side you want to go.
Yeah, and the latency really depends on the application. That's also why we have multiple options. If you use only stored procedures who do everything, reducing the round trip and with the right leader placement, you can have complex application with which do not suffer from the latency. Basically, 100 milliseconds, if you have only that once in a user interaction, that can be okay for the user. But if the application is running 10 transactions with 100 milliseconds, then the user will feel it. So that also depends on the design on the application.
Yeah, makes sense. Makes total sense. Yeah.
So if there are no questions, I have here a quick summary of the things we have seen. So single region, that's the lowest latency, but no regional fault tolerance, only restoring a backup. So that's a possibility, depend where the requirements. Multi-regions, and there are also multiple options for multi-region. We can stretch the cluster. We can also have follower reads. They can count in the quorum or be with replicas. We can do geo-partitioning. Also duplicate indexes. That's also something we do with geo-partitioning. We partition usually the big tables, but the reference table that you want to be in sync in all regions, that can be the duplicate covering indexes. So something else, I think we had a session about it. And cross-cluster, when a difference also with cross-cluster, you decide per table. So maybe you have only some tables that you want to replicate, to read in another place. So you have this additional flexibility. If you want to replicate all tables to read them elsewhere, probably read replicas are better. Cross-cluster is more about DR, so you have the maximum performance, no performance impact, but a data loss and probably manual decision about it.
Mm-hmm.
And yeah, and with cross-cluster, you can balance the load if you write different data sets. I don't know if it's in the latest version, but we are also taking care to be sure that the application will not connect in different places. So really declaring which one is primary and which one is standby, so that the application cannot connect on the wrong place.
Got it. Awesome. So Kurt has a question. What do you mean by async in the stretched cluster case? Not based on replication? That's his question. So
in the case of stretched cluster, it's not async, it's sync with a quorum, or maybe that was about the follower reads and read replicas. Basically, the followers are in sync, but within a quorum. So then the one that is in another far region will probably this is the equivalent of async. If you are sync but acknowledged from a closer region, then the other one is equivalent to async. And the read replicas, they are really async because they are not part of the quorum.
So they don't participate in the writes, Kurt. They will get the changes in order. So and the schema changes everything in order. So they are a good stale copy, but you don't need to replicate to these read replicas in order to hack your write. So that means you can keep your write latencies relatively low by putting them in one set of regions, but you can distribute the read load closer to different regions by moving them closer, right? And this is different from xCluster, which is like true async in the sense they are two independent clusters. In the case of read replicas, they are a single cluster and you're using the same log and the timestamp and everything to replicate, schema change, all of that stuff. Yeah, well, fair. He says the terminology is a bit tortured. Well, fair point. I think this is something we are reworking in terms of how to explain it as user value or deployment value rather than technical components. So fair point.
Yeah, the terms also come from traditional databases. Sync and async. Yeah, it's more about latency, not waiting for them. Yeah. Mm. Okay, and that's all I have. Do we have more questions on it? So many possibilities, many options. The simplest ones are probably good for many cases, but we cannot change the latency between regions, but we can change the way it is replicated with a balance between performance and data loss.
Awesome, fantastic. I think this was a great talk, Frank. This is awesome. We started all the way from application design all the way down to what are the possibilities in the cloud native world, right? So thank you so much. Once again, folks, thank you for joining us. Join us again next week, same place, same time. And in the meanwhile, if you have questions, once again, ask away on LinkedIn, or post it on our community Slack, as Franck has the URL. Just join the YFTT channel, and we'll take a look at it. Yeah, and Kurt says thanks. Yeah, thank you, Kurt, for joining us as well, and all the others. So thank you, folks.
Thank you. Have a nice weekend also.